Thank you, everybody, for attending this session. I would like to present you this subject that I was really interested in. It was to create a kind of node service based on Hazelcast. And I've put a question mark because obviously there are many things that you have in that you don't have in Hazelcast compared to answer that question. Okay. So here is the overview of the presentation. It's basically an introduction to Hazelcast for people who don't know anything about it, just to give you an overview of what is possible and a bit also how it works, and with some code samples, some small examples. Can I ask you a question? I would like to know how many of you do already know Hazelcast or similar tool. Okay, thank you. And after that, the idea was to go through, how to use it with, in the context of Alfresco, in a different way, different to the way it's used now. In 4.2, we have changed our caching layer and we have switched to Hazelcast. And basically, the idea is to use new features or other features from Hazelcast in order to use it as a cache, if I can say it like that. Then the second, the third point was to go through a POC, proof of concept. And after that, I would appreciate a lot if you could give me some ideas or some feedback about the concepts that will be showed here, okay? And maybe some conclusions. So what is Hazelcast? Hazelcast is what's called an in-memory data grid system, meaning everything is almost stored in RAM. You can offload the values. Let's say if you have a hash map, you can offload the values on a persistent layer, but basically it keeps everything in RAM, okay? So one interesting characteristic about Hazelcast is that you can scale up by adding or removing server seamlessly without disturbing the other members of the cluster, or not, having any perturbation at the service level. Another characteristic, obviously, it's a non-relational no SQL system that does data replication. It also can be interesting in terms of geographic replication, and it can scale up and down linearly. It's possible. There is another point that comes up. It's the resilience. It means what happens if I have a server crash or whatever. Obviously, in this case, you use replicas, as we're going to see in next slide, and we can achieve resilience by managing replicas. That's also another point, because you can say, well, everything is in RAM, something crashes, what happens? So, in terms of, yes, the last point is about the data structures that Hazelcast can manage. It's basically hash tables and derivatives, like a multi-map, which is like an hash map, but where to one entry it can correspond many values. It's list, and also other interesting things is that it includes a messaging system and also a future system, meaning you can execute piece of code on one of your nodes asynchronously and get the result later on. So you can post a task, do something else, and get back the results. And the things that makes me think that we could do more with that system is that it's kind of easy to use, and also it integrates with Spring. which is also another interesting characteristic of the Hazelcast system. Here is just a slide showing how you can achieve resilience by replicating nodes. So in this case, you have 5 million objects on 5 nodes cluster. Then each node will carry 1 million of its own objects, of its own data, and then 1 million for the resilience for the replication. It's just repeating the type of data structure that can be used in Hazelcast. So you have distributing concurrent map. This aspect is quite important. You have multi-maps that I already mentioned before, the sets, the queues, the list, distributed topic, which is more like a listening system, listening pattern, and messaging. Just to mention the fact that I've written a small introduction to Hazelcast, and I've uploaded it into the the presentation material. Okay. Just having a look at that, if you want, just trying to give you an idea about what's in the Hazelcast and how it works. Let's take this small example. This is why I said it's quite easy to learn it, because it's just as a usual map. Okay? So nothing much different. One of the main difference is when it comes to get the value from the map. When you get the value from the map in Hazelcast, you don't get the element itself. You're getting a copy, you're getting a clone. Therefore, when you're developing stuff using that tool, you have to think about it, not thinking you have the object itself, but you're manipulating just a clone. Therefore, to take effect, you have to put it back in the map to make it visible by the other cluster members. If you don't put it back in the map, it's like if you wouldn't write into a database, okay? And the other element when you work with Hazelcast is that you have to have a good candidate for your hash key, because he won't use the hash key, the default hash key and stuff like that directly provided by the object itself. It just takes the key, it serializes it as a byte array, and then it uses that as a hash key. Yeah, That's the two main things I think that is important, that are important. Other elements that are important as well, yes, it's when it comes to get back the key sets. The key set is also a clone. It's not the actual key set. It's something that is pulled out of the cluster and built for you by Hazelcast. Another element that I did not yet mention is the fact that Hazelcast is able to manage transactions. And as you know, it's very important, and in Alfresco we use a lot of transactions. Therefore, the idea was also to, when I mentioned the fact that it was a different way of using Hazelcast, we use it in Alfresco until now for messaging for, we're still doing some invalidation of caches, but it's not the referential in the sense that we still refer to the database that has the truth about what's happening at one moment in the system, and as the database that is used to manage the integrity of the whole system. And here I came up with another idea that was to use Hazelcast in order to manage the transaction itself, and in terms of values, the possibility that is offered by Hazelcast as well is to write asynchronously the changes into the database. Therefore, you have a decoupling between the persistence layer and the transactional aspects. Meaning you can change stuff and then in the cache, and then after that it will be flushed into your persistence layer. This is also something that I try to demonstrate in the POC proof of concept. The first idea that I did the first proof of concept, if I can say it like that, but it was basically I just rewrote a small part of the NodeService, which is the QName DAO, the persistence object for QNames. But I wasn't happy with that because obviously you have the problem here. I did a sequence diagram showing that the interaction, the different interactions in that object when it comes to use it and how they interact with it, the different classes. But the problem is obviously if you have a failure between the two commits, the commit in the database and the commit in the Hazelcast, and you can have a kind of desynchronization between the two, and obviously it's heavy to manage to keep the two commit in sync and be sure everything is in order. Therefore, I gave up with that idea because also it didn't offer the possibility to decouple the writing of the data to the persistence layer and the operations, the actions that you were doing into your cache, okay? So I think, here I have to mention something also that is really important. In terms of operations, or in terms of managing transaction in Alfresco, what we need is a certain isolation level, which is repeatable read. And that is also offered by Hazelcast. And then I thought, well, we could use that as well because it's provided by the Hazelcast, therefore it could work because it offers the same isolation level. Okay? Hazelcast offers, as I said, the transactional aspects. So you can manage transactions and having the same isolation level. And also, the other things that I did into the small prototype is to write in a persistence layer, which is MongoDB. Therefore, and why did I choose in my prototype to marry the two technologies? It was because one was offering the transactional aspects, whereas MongoDB does not, as far as I know, and it's quite heavy to manage and low level if you want to have transactions in MongoDB. And the other thing is it was giving the possibility to not be tied up to the speed of the persistent layer, but being tied up to the speed of your memory cluster. To decouple the two aspects, to decouple the constraints, let's say. How did I do the prototype? I used Maven, and I used also a couple of libraries that are already available that allows you to configure the two things together, Hazelcast and MongoDB, and obviously the glue is, as usual, a Spring framework, okay? Here is a small example of configuration. First line is about to configure your connection to your MongoDB persistent store, okay, to your MongoDB store. Then you have a MongoDB template, which is a second object that uses your connection, which gives you some parameters about, the database name and stuff like that. It's a bit of a context, let's say. And the other one is a Mongo map store. This is the object that makes the glue between Hazelcast and MongoDB, meaning this is that object that will be responsible to write the things and do the mapping between the fields that you have in your Java objects, in your Java objects, and it will do the mapping automatically to MongoDB. So it will store that. You don't have to configure the mapping yourself. It does it for you, which is very handy and kind of flexible, and also you're not drawn into configuration as with other systems eventually. And then you declare your HMAP. You declare that it's just a map that uses the configuration that you did before. In this case, the write delay is 0 seconds, meaning it's written synchronously. Whereas if you put a higher value, if you accept that the write could be made after, then here is an example that shows how to use transactions in Hazelcast, and it's really straightforward. You don't have to do something really special. It's really classical in terms of transactions. You just get a transactional map, and you do your operations, and you do a commit or a rollback, and that's it. Nothing very complicated there. It works almost transparently. And then it came up another problem, because obviously, as I mentioned before, you don't have all what you have into, Alfresco, the node services. It relies on a database. Therefore, if you think about a unique key, or if you think about foreign keys and stuff like that, it doesn't exist in Hazelcast, really. But you have other tools. And what I try to also implement is to show that it's possible to implement that stuff, that type of stuff, like a unique key and foreign keys using Hazelcast, because there is another tool that I did not mention before, is that you have a row locking in Hazelcast. Therefore, if you think about database, you have some database that are doing row locking. Therefore, the idea is to use it a bit the same way, and do what we do in Alfresco. When we start a transaction, we are using the retrying transaction helper that retries the transaction. Therefore, it would be the same, basically the same principle, the same way, no different pattern there. That's how we could implement and manage the concurrency. There is something else that I also thought that would be nice to avoid, in my opinion, is using sequences. Why am I saying that? It's because sequences is kind of difficult if you think about systems that have to be reconciliated. Let's say, let's take a use case where somebody works home and he wants to reconcile the data that he has produced home and reconcile it when he's connected to a network. In this case, the sequences are quite difficult to manage. But if you think about using a UUID as an identifier, as an object, as the primary key, then you can use stuff like timestamp and decide how you're going to resolve the conflicts. I think it opens some possibilities that are quite difficult now as well. Also, yeah, another problem with Hazelcast and the sequences is that they don't survive a shutdown. Meaning, if you shut down completely a server, the sequences, they start at 0. As I said before, the main challenge was to have, let's say, enforce uniqueness. How are you going to do that? What I did was to use a secondary HMAP. Just now, there is something that I'd like to explain is the fact that if you think about the transactional maps, they don't have the full power of what the other HMAP in Hazelcast have, in the sense that there are some operations that are not possible in transactional maps. It's probably pretty unclear what I'm saying here. How can I explain better? You have a map which is non-transactional, meaning if you obviously the write operations, the read operations are atomic, but you cannot change, do a real transaction. Then you have to build, Hazelcast offer the possibility to build a kind of proxy around your map, and that proxy has all the functionalities. What it offers you, it's the transactional aspect, but it doesn't offer you, let's say, the select or the search. This is something I didn't say as well, is that in Hazelcast you can declare some index on your values. Therefore, you're not obliged always to go with the primary key, with the key of the map to retrieve an element. You can go using an index. And that index is also maintained for you in Hazelcast. This is one of the power of the tool. Basically, I'm not good at drawing at all, so it shows the key, and then it's like an H key, basically. And it gives you the possibility to access using values, and directly it points to the entry in the HMAP. I have a small prototype, let's say, and that I would like to show. I don't know if it's very readable. Basically, what I do here, it's where I'm testing that concurrency that I spoke before in terms of guaranteeing the uniqueness of a key. So in my test, what I do is I get an instance of Hazelcast, then I clear. It's just flushing all the data that is in MongoDB and eventually into my Hazelcast cluster. And it's also given for free. If you go at the top, when I mean given for free, is that here I just say map clear, but with the same operation, it's the map in memory and the map, and also the persisted map in MongoDB are also cleared. So I create a set of futures, pool of 20, And then I start to execute my test. And after that, basically, I go through all my futures and I wait that it's finished, and then I'm checking the the results and see if I don't have any duplicate keys and stuff like that. Okay, that's what I'm doing here. Okay. So it's just going through the maps itself and checking the uniqueness. And here, this is the test itself. In fact, I mean, so what I'm doing, I'm generating random numbers that will be basically the keys that I would like to be unique. And what I wanted to do is that if you come with those keys and you do it in a transaction, I want it to be unique. I don't want somebody else. Somebody would write the same number into my table, the same key. And I try to manage the concurrency using Hazelcast and the logs. I'm using try-log to try to get the unique access to that row. And then after that, I'm putting the values in the map, and then it's committed, basically. Yeah, it's committed or it's rolled back. That's what I'm doing in the example. So you can have a look at the example and try to understand what is done in terms of locking and uniqueness. But normally, if I run the test, we shouldn't have duplicate keys. Normally, it should work. The first test is about to adding stuff and see if it's not there after the I run it as a debug. It's not good. Sorry. Okay. So basically the test passed. In the first test, I'm checking that the rollback works or the commit works. Just inserting data and then doing a rollback and checking that that none are committed basically. The second one is it's more to see if basically the commit worked fine. And next one is to test the concurrency between different threads and trying to do something and checking that integrity works fine as well. It's very restricted integrity check, obviously. And the next one is just adding namespaces and seeing if they were committed properly. You have a couple of other tests that are there already that you can look at it and see how it works if it interests you. Then maybe to try to, go to some conclusions or some remarks. For me, it appeared to me that it was quite heavy work to recreate all the richness and all what we have into the Alfresco node service. That was quite a huge work, obviously, given that Hazelcast only offers a kind of low-level interface in terms of all the transaction management, or more the uniqueness of the keys and the foreign keys and all those stuff were not existing in Hazelcast, so are not existing in Hazelcast. So it has to be recreated, and the algorithms have to be retaught, and probably we can establish some patterns that would ease the development, and using Spring to abstract some patterns that could be used recurringly, repeated. That's one point. So in my opinion, it's a huge work. The other thing is, we won't cover all the functionalities. So what for would we use such a node service based on such concepts? I think the answer is the scalability, because I've observed in kind of some projects where it comes to deploy or publish publish content. It comes that we're using a file system basically, or we can publish in Alfresco, but maybe it doesn't correspond exactly to, or cannot fit the load it will be hit with. Therefore, maybe a first use of that type of node service will be to give you some possibility to deploy, but being able to accommodate to the load, because it's based on clustering, it's based on replicas, it's based on, it's supposed to be technologies that are scalable, okay? That are more scalable. So basically that's my conclusion. And I don't know if you have some questions, or if you... I'd like to know what you think. If you think it's not a good idea, if it's a good idea, if what you do, could it be helpful, or that's my purpose here.
Hi, thanks for that. That looks really interesting. I was wondering, you're showing how using Hazelcast hash maps can persist all of these objects. I'm wondering how you might then, at the next level, map those to domain objects. So how you might handle the relationships between properties, associations, and things like that.
Yeah, I understand. Okay, the first idea is to, well, in the database, what we have is basically a table for associations and for child associations and properties and so on. So the first idea that could be, good, or the good idea could be to having maps replacing the tables, basically having a one-to-one. But I'm not sure it's fully it's really, yeah, there is something like that, but it's not maybe the really good idea. It could be better to try to divide. I mean, let's say in Alfresco you have many, you can think, well, we have stores. Why not creating a couple of H maps for stores? Why not creating the set of maps necessary to a tenant and stuff like that? So I don't think the good idea is to keep everything into a big table, but more having a set of data that will be the intersection between everybody. I mean everybody, not everybody, but all the different parts of software, and then sharing those things that must be shared and having separate H maps to represent the things, the associations and the properties and stuff that we manage in Alfresco. I don't know if that answers the question.
Yeah. I guess it does. I guess when I look at it, the first thing I want to do is store a really simple, business usable, high-level object directly in a Hazelcast map. So construct some complex idea of a node, and then just store that straight in the hash map, because then you avoid all of the complexity of mapping into relational tables. Because this isn't relational anymore.
Yeah, no, wait, I can maybe show you if I have some elements there. Yeah. You see, it's persisted into Mongo. And that's how it's stored in Mongo. Yeah. So it persists the Java objects. Another question, maybe, if somebody else is interested.
I was wondering how is, when you're storing objects in this Hazelcast map, how is it getting persisted? Is it some global event mechanism that's triggered, or is it a manual operation?
I didn't went into the details of the implementation of that persistence layer, but it's given by an object, a class that's called map store. And you have a map store for Mongo provided by Spring Hazelcast integration. And basically, I think it listens to events.
Okay,
so it's a listener.
Hazelcast is publishing an event. Okay, this was modified, and it's hooking into that.
Yeah. And I think it can also, when you commit, it can spread the load of the writing on different nodes. I think it's possible. You can, distribute the treatment of writing. You're not obliged to write everything on one node. From one node, you can write other things from other nodes.
Thanks.
That question just made me think of something. So, am I right in thinking that Hazelcast essentially stores 100% of the objects in its cache? So if I do a read from Hazelcast, will it ever go to the database? Or is that only when you start the server up?
No. You can define in Hazelcast eviction policies. Therefore, the value will be persisted and can be removed from the cache. But if you read it again, it will take it out of the persistence layer. So you're not obliged to have everything in memory. You can also offload the objects into the persistence layer. Yeah. But the keys must be in memory. And also, I presume the index. Something I didn't show, but it's into the examples, is that you can, on objects, you can define, on classes, you can define easily indexes. Okay? I can show you that. I can't remember if it, It's into my, so mapping, where is it? Yeah, it's this context. So for some maps into my small prototype, I use this tag telling that if those objects must have two methods, two getters, the set first and get first and get second, okay? And automatically Hazelcast will build an index on that. Meaning, in your code, if you want to do a select with predicates, you can also do some kind of complex search as well. It's a bit like SQL, not as powerful because you don't have to join between other tables, but it's also kind of powerful, yeah. Don't know if there are other questions in the assembly or...
So this may be more a question about Hazelcast. So you have a distributed map on multiple Hazelcast instances.
Yes.
And so a few objects live in instance 1, a few objects live in instance 2, right? And you want to update in a transaction an item from instance 1 and an item from instance 2. How does the...
It manages the... When you write the code, you can specify when you manage the transaction if it's double phase or single phase commit.
So you can say, I want to just
if you
have
get
a local transaction or a multi-phase
exactly. Yeah.
transaction.
Yeah. Obviously, you will have your payload for multiple, double phase commit, but that's how it works. Yeah.
And does the client know at which instances the objects actually live, or is it you contact one Hazelcast and they commit?
For you, from developer perspective, it's totally transparent, but you can also influence and say, I showed something, I showed the futures, and then those futures, they can be executed on a particular node. You can say, you can have affinity and say, okay, well, I want it to be executed on my node. And also, maybe another element in the same order of ideas that I didn't mention is the fact that Hazelcast can provide also to you local caching, meaning you can define easily local caches in the instance where you are working on, where you live. Therefore, you don't have to go and having the round trip on the network every time you want to access something. You will have it locally. The risk, in quote, is having stale data, meaning data that are not really up to date. But what I've seen so far is it's quite fast. I mean, the local caches are invalidated quickly. That in some case you can live with that. If you imagine tables that are referenced a lot of times, and all the time they are the reference like namespaces. You can say, well, they don't evolve that quickly, they change rarely, so you can live with a local cache, obviously. That's one thing. Another thing is, if you think about Hazelcast, here I showed like it's a symmetric cluster. Every node has the same functionality. Functionality is attached to in the cluster. Therefore, you have another way to work with Hazelcast is to be a client of your cluster. Your virtual machine won't have any instance of your distributed object on it. You won't consume any memory, but you will just be a client of a cluster. That's another way to work with Hazelcast. And the third way, that is, the product has also a commercial component. It's elastic memory, I think. So it's also something that was created by Hazelcast, but not fully, not published in open source. It helps to manage big heaps. Sometimes when you manage heaps, it's difficult to tune the JVM to find the good options and being sure that your memory does not explode after a certain time. In this case, they say that managing that for you. And also the last thing that I would like to say maybe is that, well, sometimes I found in Alfresco, the clients are buying huge hardware, big machines, but it's sometimes difficult to take advantage of it. Maybe techniques similar to that could be, helpful to take advantage of it. I mean, the huge amount of memory they're buying. I've seen clients buying machines with 70 gigs. Not sure we can fully use that on a clever way. Just because a heap of 70 gig, I'm not sure JVM manages it perfectly. Okay. Another question, maybe? Okay, thank you. Thank you very much.